Yeah. The concept is say what you need with some people do combine them. And there are that's not all. Though caveman itself costs apparently, there were cases where accurate.
I'll be honest, I don't really read Claude Code's responses anymore.
Where's this coming from?
Because they're so long. I just want the conclusion, but there's all this preamble and extra context first. I appreciate the thoroughness, but my eyes glaze over halfway through, and I end up just reading the last part.
Oh, I get that. When you ask for a code review, it starts with background context and takes forever to get to the point.
Exactly. Then I'm scrolling around trying to figure out what I'm actually supposed to fix.
Shari, there's a skill that fixes that. It's called caveman.
Caveman, like cavemen?
Yeah. The concept is say what you need with fewer words. It cuts LLM output by 65% on average. It launched this April, and in 3 months it hit 86k stars. It came out after RTK but overtook it.
RTK's the one that compresses the input side, right? So this is a different thing?
RTK trims what gets fed into the LLM, while Caveman trims what the LLM sends back. In their own benchmarks, the reduction ranges from 22 to 87%. And the longer the response would have been, the more it cuts.
So for some tasks it's cutting almost 90%. That means way less to read too.
Exactly. It's not just about cost, cutting down reading time is a bigger deal than it sounds.
What does trimming input versus trimming output actually look like?
They compress at opposite ends. RTK trims the input before it reaches the LLM, thinning out shell output, like from ls or git diff. Caveman does the opposite. It makes the LLM own answers shorter.
So they're squeezing the entrance and the exit separately.
Right? So they're not competing. You can use both.
Is the implementation totally different too?
RTK is a CLI proxy written in Rust. It processes shell output before handing it to the LLM. Caveman is a system prompt skill. It just injects an instruction telling the LLM to answer briefly.
So a binary versus a prompt, that's a huge difference in how easy they are to set up.
With Caveman, you just curl the script down and you're done.
So what happens if you run both together?
Some people do combine them, and there are reports of 15 to 95% reduction.
95%? That's basically nothing left.
Depends on the workload, but trim both the input and the output, and the effect multiplies. RTK shines when there's a lot of shell output, like ls, git, or pytest. Caveman shines when the response would otherwise run long, like reviews or architecture discussions.
So it's not either or, running both is the right move. Just telling it to answer briefly in the system prompt cuts 65%. Really?
Caveman's core is a rules file called skimming, and it's very specific about what gets cut. First, articles, drop a, and the entirely. Next, filler, words like just, really, basically, actually, that don't change the meaning if you remove them. Then politeness markers, sure, certainly, of course, happy to, that kind of thing.
LLM really do pile on the preamble and the little acknowledgements.
It cuts all of that, and it's fine answering in sentence fragments too. Extensive becomes big. Implement a solution for becomes fix. That kind of thing.
So it standardizes on shorter synonyms, but that's worrying if it starts trimming code too.
That's explicitly protected. Code, commands, error strings are preserved byte for byte. It only trims the prose. It never touches anything technically load-bearing.
That's reassuring. If it started shortening variable names on its own, that'd break things.
And here's a surprise. It actually bans custom abbreviations.
Bans abbreviations? Isn't the whole point to shorten things?
Things like CFG, IMPL, or FN tokenized to the same number of tokens as the full word. So it doesn't actually save anything. It just hurts readability, so it's banned outright.
Looking shorter doesn't mean anything if the token count doesn't actually drop. Okay, I get the rules, but how much does it actually change in practice?
There's an example in the README, asking it to explain a React re-render issue. In normal mode, it starts with, the reason your component re-renders is most likely because it's creating a new object reference on every render, and then continues. When you pass an inline object as a prop, React's shallow comparison sees it as a different object every time, and ends with, I'd recommend memoizing it with use memo, 69 tokens total.
Thorough, sure, but yeah, that's a lot of preamble.
In caveman mode, it's new object, ref each render. Inline object prop equals new ref equals re-render. Wrap in use memo. That's 19 tokens, a 72% cut.
All the necessary info is still there, and it's less than a quarter the length.
Ultra mode cuts even more. Inline obj prop, new ref, re-render, use memo. It drops even the connecting words. If one word will do, it stops there.
Sounds like a telegram, readable but right on the edge.
There's also an odd one out Wenyan mode. It answers in classical Chinese.
Classical Chinese?
Classical Chinese packs a lot of meaning per character, so it apparently cuts 80 to 90% by character count.
Not much use if you can't read it, but for languages with expensive tokens that could actually help. How much hassle is the setup though?
Just curl the script down, one line. There's an official install sh, and if you're on Claude Code, you can also install it with the plugin command.
Does it work on Windows too?
There's a PowerShell version of the script for that.
Once it's installed, do you have to type caveman every time?
On Claude Code, it turns on automatically from the first message. A hook writes a flag at the start of the session, and it just activates on its own.
So you don't have to do anything. What if you want to change the level?
You just type /caveman light or /caveman ultra to switch. Light just cuts filler, that's the light mode. Ultra strips it down to the extreme. Even conjunctions get cut.
And to go back, you just say normal mode, right?
Right, oh, and there's a handy one. /caveman commit generates commit messages under 50 characters.
Shorter commit messages too. That's actually kind of nice. A 65% reduction sounds huge, but does it drop that much for everyone?
The author's actually upfront about that. It clearly works for some people, and not for others. It works well for tasks where a single response runs over 1.000 tokens. Things like architecture discussions, code reviews, debugging explanations.
So the more verbose the response normally is, the more room there is to cut.
And on the flip side, it doesn't help much if you're mostly doing short Q&A.
Short questions don't have many tokens to begin with, right?
That's not all. Though Caveman itself costs 1 to 1.5k tokens as a skill. If a plain response is only around 150 tokens, the skill's own overhead ends up bigger than what it saves.
So the cost of loading the skill puts you in the red.
By the author's rule of thumb, if your normal responses usually run over 1.5 to 2k tokens, you'll definitely come out ahead. Below that, you might actually lose out.
Is it the same story with something like Cursor?
With Cursor, there's actually a report of it backfiring. 3M tokens versus 1M.
That's more than 4 times as many. Why would that happen?
Apparently things like rule reinjection and retries, quirks in how it manages context, can flip the outcome. Also, with per-request billing like GitHub Copilot, it doesn't help at all to begin with.
Fewer tokens doesn't matter if the request count stays the same, right?
But what the author's really getting at is that the real win isn't cost savings. It's saving reading time. Shorter responses are faster to read. That holds no matter what the billing model is. Anyone gets that benefit.
That I end up skimming past it, problem Sharina brought up earlier. If this fixes that, it might actually be worth it. Feels like making it shorter would drop information and hurt accuracy, though?
Yeah, that's the natural assumption. But there's an interesting paper on this. A paper from RZiv. This past March found that having the model answer more briefly can actually improve accuracy, more so for larger models.
The bigger the model, the more it helps. That's the opposite of what I'd expect.
Apparently, there were cases where accuracy improved by up to 26 points.
26 points isn't noise. That's a real difference.
The idea is that cutting the redundant explanation actually lets it focus on what matters.
Even with people, talking longer can make the point drift.
Caveman's official README actually cites this paper as backing for it.
So there's academic grounding behind it, not just anecdote.
Caveman doesn't just cut output, it can also trim the input side.
Wait, it can cut input too. I thought output compression was the main thing.
There's a command called /caveman-compress that compresses memory files like CLAUDE.md. Once you compress it, it keeps working in every session after that. A permanent cut to input tokens.
So it's not redoing it every time, it actually rewrites the file itself.
In the official tests, memory files got cut by 46% on average.
Cutting almost half opens up a lot of room in the context window.
Combine that with the main output compression, and Caveman alone handles both input and output.
Nice, that one skill covers both sides.
There's also something called Caveman Shrink, which compresses MCP server tool descriptions too.
Tool descriptions, those load into context every single time, right? So that can be trimmed too.
The more MCP tools you add, the more tokens the descriptions alone eat up. It quietly adds up. Julius Brussi also has other related tools besides Caveman, you know.
Like the Cave series.
Right? Caveman compresses what the agent remembers. When you carry memory across sessions, it lightens the memory itself.
So it's not the output, it's the memory that gets compressed.
CaveKit is a spec-driven build loop. You write a spec, then build against it. There's also CaveGemma, which fine-tunes Gemma 4 with low RA.
So it's cave-manified at the weight level.
Instead of instructing it through the prompt, the model itself is trained to answer concisely.
That makes the cost of loading skills basically zero.
There's also Caveman 2 in development, apparently planning a team-level measured dashboard.
Right now /caveman stats is just a local estimate. Teams probably want real measurements. So, is there a clear standard for whether I should use this?
If I were trying it, I'd turn it on for days when long replies are expected, like PR reviews or architecture discussions. Days where the work keeps producing responses that go over 1,000 tokens each.
So on days that are mostly short Q&A, better not to turn it on.
Right, the skill itself costs 1 to 1.5k tokens, so the overhead ends up outweighing what you save.
So it's not just hard to feel the benefit, it could actually put you in the red.
That's why for a first try, aim for a day full of long replies. Once you feel it's working, switch to using it all the time.
What about combining it with RTK?
They don't conflict, so using both is totally fine. It cuts both input and output.
For Sharina, less reading might matter more than cost savings.
The author himself says that's the real point. Shorter replies are faster to read. Regardless of the billing plan, that's something everyone gets.
Guess I'll try it on the next big review day.